Good morning, Miss Yin.
Good morning, class. I'm Miss Ian. Today I'll be talking about the minute hand and hour hand of an analog clock. I believe you guys always see that the minute hand and hour hand point in the same directions, meaning overlap at a certain time. Have you guys ever wondered as to how to calculate the exact times, like from 6 p.m. to 7 p.m., the exact time where these hand point in the same directions? You might be thinking, what kind of question is this? I can see with my own eyes that these hands overlap at maybe 6:32 or 6:33 p.m. But how sure are you that they really overlap at these times? What if the angle between these hands is 0.001 degree that you cannot see with your naked eyes? And what if I want to find the exact time that this hand overlap, for example, 6:32 and how many seconds? So today I will show you the solutions to this kind of problem. So here's the questions. At 12 p.m., the hour and minute hand point in the same directions, which means we have a minute hand pointing at 12. We have the hour hand pointing at 12 as well. So what is the exact time between 6 p.m. and 7 p.m. when the hour and minute hand point in the same directions? So in order to solve these questions, I will need to use the idea of linear motions to find the catching up time. So let me show you this diagram. Okay, imagine there are two objects on a straight line. Okay, and the first object is 15 meter ahead of the second object. So maybe I put this as 50 meter. And let's say the first object has speed 3 meter per second, and the second object has speed 8 meter per second. So from here we can see that the second object can definitely catch up with the first object because it's moved faster. So what we need to find is in 1 second, how many meter can the second object catch up? So in order to find this, we can find the difference of their speed. So the difference of their speed is 8 meter per second minus 3 meter per second, which is 5 meter per second. So that means the second object can catch up 5 meter in 1 second. So to catch up 50 meter, what we need to do is use 50 meter divided by 5 meter per second. So the second object needs 3 seconds to catch up with the first object. And this can be verified by showing this diagram. Okay, let's say I put a second object, which is 50 meter from the starting point. And the second object is at the starting point. So after 1 second, the second object traveled 8 meter. So it traveled 8 meter. And within the same time, the first object traveled 3 meter. So after another second, the second object traveled another 8 meter. And within the same time, the first object traveled, so 3 meter. And in another second, the third second, the second object traveled 8 meter. And the first object traveled another 3 meter. And we can see that at this time, the distance traveled by both objects are not the same, sorry. The distance of this object from the starting point are the same. You can see that the second object, it has traveled 3 times 8, which means it is 24 meter from the starting point. Whereas the first object, it is also 15 plus 9, which is also 24 meter from the starting point. Since they have the same distance from the starting point, which means they are in the same positions, this is the time they meet. This is the time that the second object catch up with the first object. So you can see that we can use the idea of difference in speed to find how much can the faster object catch up in 1 unit of time, like 1 second or 1 minute. So we can use the distance that it needs to catch up, divide by the difference in speed to find the catching up time. So next, this is the idea we will be using to solve the question I showed you just now. So next we try, let's go back to the question. So, and at this time, 6 p.m., we know that the minute hand points at 12 and the hour hand point at 6. And we can see that the difference of angle between this hand is 180 degree. And we can understand these situations like the minute hand is left behind by 180 degree. So it needs to move faster to catch up with the hour hand, which is also moving but very slow. So in this case, we will need to find the speed of each of these minute hand and hour hand. And also, as the tip of this minute hand and hour hand move in a circle, so the speed of this hand will be calculated in degree per minute. And we also know that the circumference of the clock is split into 60 small interval. What I mean is from 12 to 1 we have 5 interval, from 1 to 2 we have 5 interval, from 2 to 3 we have 5 interval. So in total there are 60 interval. So to find the angle in each of this interval, we can use the total angle in the circle, which is 360 degree, divided by 60 interval. Then each interval is 6 degree. Okay, so next we will need to find the speed of the minute hand and hour hand. Okay, let me put down speed of the minute hand. Okay, so we know that the tip of the minute hand travel one circle in 1 hour, which means we know that the tip of the minute hand travel 360 degree in 1 hour. It travel 360 degree in 60 minutes. So I'm going to use 360 degree divided by 60, and we have 6 degree per minute. And as for the speed of the hour hand, okay, so for the tips of the hour hand, it only travel 5 interval in 1 hour. Try to imagine at 6 o'clock, the hour hand points at 6. But after 1 hour, the hour hand will be pointing at 7, which is only 5 interval away from 6. So from here we can see that the hour hand travel 5 interval in 1 hour. And we know that 1 interval is 6 degree. So 5 interval will be 30 degree. So which means the hour hand travel 30 degree in 1 hour, which means 30 degree in 60 minutes. Then we will have 30 degree divided by 60, which is 0.5 degree per minute. And as you can see from here, the minute hand can definitely catch up with the hour hand as the minute hand travel faster. So next we will need to find how much in angle can the minute hand catch up in 1 minute, and this can be found by finding the difference of their speed. So we have difference in speed, which is 6 degree per minute minus 0.5 degree per minute, and this is 5.5 degree per minute. So this difference in speed, it means that this 5.5 is the angle that the minute hand can catch up in 1 minute. So click it down here, minute hand, catch up 5.5 degree in 1 minute. So as I explained earlier, the minute hand is left behind by 180 degree. So it needs to catch up 180 degree to catch up with the hour hand. So it needs to catch up 180 degree, and every minute it can catch up 5.5 degree. So to find the time that the minute hand can catch up, we have to use 180 degree divided by 5.5 degree. The angle that it needs to catch up divided by the angle that it can catch up in 1 minute. So from here, we can simplify these fractions as 360 over 11, which also can be simplified as 32 over 11 minutes. So which means after 6 p.m., the minute hand needs 32 8 over 11 minutes to catch up with the hour hand. which means the mini hand can catch up with the hour hand at 6:32, 8/11 p.m. So here's the answer. So at first, this question looks strange as it involves angle rotations per minute. But once we apply the idea of linear motions to break down these questions to find the catching up time, it has become obvious and we can solve it easily. So guys, I hope you like this video. If you like this video, I hope you can recommend to your friends. That's all for today. See you guys next time. Thanks for watching.